Here then are the solutions to the Moments Physics for You sheet. And the first question says in the diagram the beams are balanced. So from that you're taking that this thing is in equilibrium. Calculate the values of weight A and weight B. Well, in A we have, if we look at our clockwise moments, we have force times distance, 2 times 0.30. Anticlockwise, we have A times 0.40. So we have 0.6 equals 0.40 times A. So A equals 0.60 divided by 0.40, which means A equals 6 over 4, 1.5 newtons. In B then, we have the same idea. We've got 4 times 0.25 is anticlockwise equals B times 0.20. So then B equals 4 times 0.25 is 1 divided by 0.20. Well, that's 1 over 0.2, which is 5 newtons. Question 2. Again, the beams are balanced. Find C and D. So, if we look at our clockwise moments, we have 4 times 0.15. We also have 1 times 0.40. There's 4 times 0.15 and 1 times 0.40. That's our clockwise. We'll add those together, I suppose. 4 times 0.15 is 0.6, plus 0.4 is 1. And that's in Newton meters, just for completeness. So, anticlockwise, we have C times 0.25. And that equals 1. So C equals 1 over 0.25, well, that's 4. 1 over a quarter is a quarter upside down, which is 4. So there's C. Then we're looking for D. Well, we've got 0.20 there times 1. We've also got D times 0.30. And that's going to equal the anticlockwise 5 times 0.40. So 5 times 0.40 is 2. So we've got 2, and then we're going to take away 1 times 0.2 over here, and that's going to be 0.2. That is D times 0.3. So 1.8 D equals 2 minus 0.2 is 1.8. 1.8 divided by 0.3. Oh, which is 6. Question 3. Well, here, unlike the other ones, every example you've got here, the pivot looks like it's in the middle. Here, the pivot clearly isn't in the middle, and so the weight which acts at the center of mass or center of gravity of something that's regular shaped like this will be in the middle. So we've got, clockwise, we've got W times 0.25, and that's going to be the same as 5 times 0.20. So W equals 5 times 0.20 is 1, 1 divided by 0.25, which gives us 4 newtons. Question 4. We have a tall crane. Calculate the size of the counterweight. Well, we have 20,000 times 30. And that's going to equal the counterweight, call it W, times 10. So 20,000 times 30, well, that's 600,000 divided by 10 is 60,000. And then B. What can you say about the position of the center of gravity of the crane? Well, if the center of gravity of the crane, the beam here, was anywhere other than right here, then you would have to consider the weight and its distance from the pivot. And so our numbers would be wrong here. If the center of gravity or center of mass was here, then we'd have to say weight of the beam times this distance plus load times this distance equals counterweight times this distance. So if this number is going to be right, the center of gravity, we'll call it in the question, must be